All right, good morning, good afternoon, good evening, ladies and gentlemen. Welcome to the series of online lessons. If you're ready, please subscribe to the channel and leave a like for this video. Now, in today's lesson, I will be evaluating these integrals. Basically, we're evaluating in a closed contour, as you can see here. So for this one, we'll be evaluating in square with these vertices for these lines, and for this one we are evaluating in this circle here. I'll start with this one, and basically the two ways that we can evaluate this, that is one by using Cauchy's integral formula. Secondly, we can use residue theorem. So basically, steps that we have to follow in all sections is that the first step is we need, so I'll be working out with white, and I'll change to, I don't know, what is this, or something. So step one is, first of all, identify region of integration. Okay, so in this case, the region of integration is this, so we can sketch it out. So that is so we have a square, so is running from +1, so this is +1 here, that will be 1 here. This is an estimate, will be +I there, positive there, I down. Okay, so all right, this is where negative, this is where negative is. Okay, so after you identify or you sketch your region of integration, you will be determining or finding the points where the function is undefined. To find the so pause are basically places where the function is undefined. So for instance, this function that we have here, it is undefined when this part is equal to 0. So pause for this, you just equate the denominator to 0. Even here, you do the same, you just equate the 0. So this will be at z minus log of 2 equal to 0. Okay? So this is where the function is undefined. So now we simply make as z subject, so z goes to log of 2, and z is approximately, let me check, log 2. So log of 2 is approximately 0.3. So now after you determine your pause, step 3, check if pause are inside region of integration. Okay, so check if the pause are inside the integration. So basically, if the pause is inside, if Z not is an element of the region of integration, then the integral Long C of f of z equals to z naught z will basically be equal to 2 pi I summing residue infinity. Okay, if we use residue theorem. Okay, so basically we can find the residue. Okay, if z naught is outside the region of interest, shouldn't be on the line. So here z naught on the line and can be inside. That's when we can integrate. So if z naught is not inside the region of integration, then basically the residue of z naught is equal to 0. Okay. Now having a start, we need to check. So as you can see, z is approximately 0.3. So z naught will be so this is where approximately 0.5, 0.3 there. So z naught is there, so it is inside, so we can find its residue. Now if z naught was outside, then we would conclude that the residue is 0. And if it was on the line, we still consider it to be inside the region of integration. Okay, so having that done, so we can find the residue and basically a residue of z naught, which is equals to log of 3, basically equal to limit z naught approaches 4, which is this one, log of 3. So is it log of 2 or let me just go back a bit. Z naught equals to log of 2, that is 4, equals to the limit z approaches. Let me write the general form as z approaches z naught, then we'll say z minus z naught times function z. Okay, so this is the residue theorem. So we'll just get our integral. Now f of z is the numerator there, okay, for the entire function. This entire thing z. Into the residue theorem, so we just have z minus the pole there, then times the f of z, okay, residue. So we have here. So now in this case, residue of z naught equal to log of 2. This is equal to the limit as z approaches z naught is 2. Here we will z 2 function. Remember our integral. Integrating, what are we integrating? That is e to the z, e to the power z. Is it 2z all over z minus of 2z? Okay. So that is what we're integrating here. For e to the 2, it's just e to the z, not 2z. It's just e to the z, right? That is just e to the power z. So now that is what we're going to put this here, where there is f of z. So here where there is f of z. So basically we're going to have here, we're going to have e to the power z all over z minus 2, like that. Simplify here. So the residue equal to, so we'll see that this and the cancels. So we just remember limit z log of 2 e to the power z. Then you can replace where there is z with, so this go to e log of 2. Okay, and basically that is there. So we can simplify this by this. So if we had a number there, or suppose it is the question I was assuming, suppose we just run to this one. So suppose you had residue of z equals to log of 2, and you had log of z approaching log of 2, here you had z minus 2, and here you had e to the power 2z over z minus 2. After simplifying, what you could have done is simplify log of z log of 2, then e to the power 2z. Then basically here we're going to have e to the power 2, which can be written as e to the power log of 2 to the power 2, which is just log of 4. So my point here is here we can simplify and simplify. So this is a must have written a different question from the one on your paper there. So, but I hope you can follow through. Okay, so from there, what you can do is so that is our residue. Our formula says we're going to have the growth of z. This is equals to 2 pi I sum of our residue 2, okay, of which it can simplify because log, let's say if z is equals to e log of 2, we can introduce logs both sides. So this would be natural log of z e. Natural log of that would just be equal to log of 2. And here we're going to have, so basically this can simplify to 2. So e to the power log of 2 will simply do, but you can just leave it like that if you're lazy to change it. So, but that will be the integral. Okay, so the steps follows. First of all, you sketch your region of integration. After sketching your region of integration, you find your poles. So by finding poles, you're just finding points where the is undefined. So after you find points where the equation is undefined, you check if those points are inside or outside. So if they are inside, then then you can find the residues. They're outside, then the residue is 0, and basically the integral of that residue is 0. So in this case, inside, so the residue is 0. So we had to find formula. Then from there, okay, now we can questions. Paste it to new page. Okay. All right, so same applies here. We need to sketch our region here. So basically, um, this breaks down as this z breaks down as x, I, y equals to 1. So basically, what you do here, you group the real parts and the imaginary parts. So that is the real parts with x plus 1 and the imaginary part by 1. And basically here, this is circle. Is a circle centered at -1, 0. On the y part, that is 0. So this is a circle centered at 1, 0, radius of 1. That is here to here, that will be 1. And it a bit from there to there, that will be. So now the circle, something like, although it's a bent circle here. So that is our region of there. So we test our region of integration. We need to find pos. Basically, we create the 0 and solve equation. So we have z to the power 3, 4, z 2, 6. This should be equal to 0. So now we go by try and error. So what number can we give us 0? So let's try x equal to -1. So we put -1 here. 1, 4. If I left out some, left out, I should have left out plus z plus 6. I think I should have left out that plus z plus 6 plus z z, and basically we put -1 there. That will be 1, 4, 6. Will it be? Yeah. -1 plus 6. This will give us 5 negative. So x equals to 1 gives us the value that we need. So there we go by. Can use synthetic division. We write -1 here. We write the coefficients of the variables here. 1, -4, 1, 6. So we write the coefficient. And simply synthetic division will bring down the 1. So then we say this times that will give us -1. So we here -2, then we add 5. -1 times that will give +5. 5 plus this will give 6. And again, -1 times that give us 6. Add 6 and it will give us 0. So now we can write the variable with this. So this is associated with z to the power 3, z to the power 2, z to the 1 and constant. So for z to the power 3, we have 1 as a coefficient. So this is 3. For z to the power 2, we have 5 as a coefficient. So that is 5z and plus 6z. Then this is just 0. So this should be 0. So we can factor out constant here. We divide throughout z. So basically, we're going to have z to the power 2 minus 5z squared, 5z plus 6, this should be 0. So here further simply, so this is z to the power 3 to the power 2, 3z plus 2 minus 2z, 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 6. Basically, z is equals to 3, z is 5 further here. So now we have z is equals to 1, 1 here of z, 1. So now our integral, this integral here can be written as integral c 5 plus 3 z 2 all over. So this can be written as using and transpose the constant, that is z minus 3 times z minus 2 z plus, what we're going to have is z minus 2 z 2 z minus 3 z z. Now we need to determine if these poles are inside or outside. Basically, their residue will be 0. So basically, using the residue theorem, this should be equal to 2 pi I sum of the. So we should just find the residues and basically it. So this is the boundary going up +1, going down up 1, here at 0, and here, since this is at 1, so this is a 1 unit circle. So we see that z is equals to 2 will be on the line, z is equals to -1 will also be on the line. This, the residue of z equals to 3 equals to 0, so we just need to find the residue is and okay, the residue of z equals to 2, this is basic limit, z approaches 2, here we have z minus 2, it's more like this. Then we have a function which is this whole thing that is here, so that is 5 plus 3, 5 plus 3z 2 divided by z minus 2 z minus 3, basically this cancel, placing where is z we place 2, so this 3 times 2 to 2 over here, this will be 2 minus 3, 2, 1. By this, so this will be 4 times 3, that will be 12, 12 plus 5, that will be 2 all over, so this simplifies to -1 and plus 2, so that will be the residue of 2. So now find the residue of -1. Okay, so the residue of 1, so we'll say residue of -z equals 1, basically equal to the limit z approaches -1. So we're going to have z this function, which is 5z 5 plus 3z squared all over z minus 3 z minus 2 z minus 2 z plus 1 z plus that's where there is z root 1, so this 5 3 times 1 to the 2 all over z is -1 1 minus 3 to 1 minus 2. This was 5 to 8 all over, give us 4 3, which basically simplifies to this times the negative times negative, that would be positive, so this is 2 over 3. Okay, so these are the residues that we have to sum. Just put them, we can just solve them. The integral from long C of 5 z power 2 all over z minus z minus 2z minus 3 z. This is basically equal to 2 pi I, summing the residue, so that is 2 over 3 plus 2 residue 2 over 3, 2. It's minus 22, so plus -2. So that will be negative 2. So this will give us 2 pi I. Then we say this is 2 minus 6 together simplify, and so this 2 pi, this will give us 64 over 3. Okay, which you can tell us simplify, but that will be answer there. So go through, take your time. See you in